Hello, everyone. I'm going to introduce the maximum specific activity of methanogenic microorganisms. And for people actually who are working on the anaerobic digestion, they know already that this is actually important parameters that can be used to uh, maybe compare different sludges or different inoculum. It can also be used for modeling. If would like to model kinetics of anaerobic digestion, maximum specific activity is also important. So the principle of determination of maximum specific activity. First, what is the maximum specific activity, which is maybe abbreviated as MSA, and it's the maximum amount of converted substrate per unit mass of biomass per unit of time. In other words, that it's actually amount of biomethane that is produced per unit mass of biomass. Biomass here is amount of microorganisms, and we are talking about methanogenesis. So this means that archaea mainly, and per unit of time. So in this case, it will be maybe milligram of substrate, acetate or propionate or butyrate per gram of biomass, gram VSS per unit time per day. So in simple form, this, if we would like to have the maximum specific growth rate equals to maximum activity, maximum substrate consumption rate, which is here, this is the maximum activity times the biomass yield coefficient. Here, the maximum, of course, the maximum specific growth rate is per day. And why biomass yield coefficient is gram VSS produced per gram COD removed. And here, this is our MX, this is the unit is gram COD removed per gram VSS per day. Okay. So again, if we would like to simplify this, so Rx equal to the change in the substrate during a period of time, dt, from 0 for certain time, divided by the amount of the biomass presented or in the reactor in this case. The conversion of COD is, of course, accompanied by the production of new biomass. This is why we have yield here. So if we would like to measure the specific activity based on the methane produced, so in this case, we would actually need to have a yield, but this yield actually is very small, maybe also can be negligible. It can be only 2% maybe of the COD converted to methane. Okay, so basically this is the units for methane, in this case COD, or methane as COD, or COD converted to methane per gram per liter. Of course, the activity depend on many factors, especially for the big scale systems, for temperature, pH, reactor type, substrate, organic loading rate, and etc. And this is just example of the activity in the big scale. But in reality, if you would like to calculate it, to determine it, so we would actually need to have optimum conditions for microorganism to work. In this case, we can conduct batch experiment, batch reactor, as we mentioned before, maybe some kind of Marriott flask or some other simple system for liquid displacement. And we include certain amount of inoculum in this reactor. And we can have a media. In media, in this case, we can have a buffer. We have volatile fatty acids because basically volatile fatty acids is, in this case, we can calculate because actually we are concerned about the activity of methanogenesis. So we would like to add acetate, propionate, and butyrate. And recommended concentration may be 2 grams of acetate per liter, gram per liter, and propionate maybe half gram of propionate per liter, and half gram of butyrate half gram of butyrate per liter. Of course, we have to provide nutrients and trace elements. So basically, you provide the best conditions, optimum condition for microorganism to grow. And this is why you calculate or you are determining the maximum activity of methanogenesis. Over time, we measure the amount of methane, again, as I mentioned, by Marriott flask, and there is a video for liquid displacement or in other system for measuring the methane production over a period of time. And then also, maybe also the specific methanogenic activity can be determined by calculating the decrease in substrate concentration over time. So either you can calculate the amount based on the specific activity based on the methane produced or based on the reduction in the substrate. And in this case, you would need to determine the composition of the media in terms of acetate, propionate, and butyrate. In fact, also you can only use one acid, but in this case, for example, acetate, you can actually just use acetate as main substrate, and in this case, you can just determine the activity based on acetoclastic methanogenesis, and you may actually, in this case, overlook other microorganisms that consume propionate and butyrate. Again, this may be more need more work because you need to calculate to determine or to measure the concentration of the substrate over time, and it will be similar procedure basically. Here, how to determine it as if we actually use the simplest way just to measure the methane over time, and then we plot this methane against time, and the after you plot the data, you will find some kind of exponential phase here, and this represent actually the maximum or the period in which the activity is at maximum. And in this case, we can calculate it or determine it based on determining the tangent to the steepest part. Here, this is the curve of methane, and this represents the change of methane over time. So what you do, you can actually maybe just get this part and plot it in Excel and get this loop, or you can actually say, oh yeah, between this time maybe day 4 and the day maybe 8, this is the maximum, and then you can get how much ml of methane be reduced through this period by the differences in the y-axis and the difference in x-axis, and you can get actually this kind of a change. And in this case, again, we are concerned about the substrate. In this case, to convert substrate, you need actually to convert the methane to COD, and using this kind of conversion, and we have explained this before, how to convert the methane to COD equivalent. And again, this is just to give you the methane produced without including the yield of microorganisms. But this, again, as I mentioned, is something like maybe 2% only. It can be as underestimation, but it can be also included. If you would like to, you can include this yield in the calculations. I would like also to the X here to explain that X here is the amount of microorganisms, and you can measure this as VSS during this test. With that, I would like to thank you, and I hope this is useful, and let me know if you have any